As you gaze into the vastness of space and witness the twinkling dance of billions of stars, each one seems to raise a silent question that has plagued humanity for generations. Are we alone in the cosmos? It is a question as old as human imagination itself, whispered in ancient myths, painted into constellations, and pondered by philosophers staring up at the night sky. For millennia, the heavens have been a mirror for our deepest curiosities, holding secrets that seemed forever beyond our reach. Yet, with each new leap in science and technology, we edge closer to finding an answer. And now, perhaps, we stand nearer than ever before to uncovering the truth. The James Webb Space Telescope, a technological marvel launched into orbit, has become our eyes into the unknown. It works like a powerful magnifying glass, offering unprecedented clarity in revealing the intricate details of distant planets, galaxies, and cosmic structures hidden in the depths of space. Unlike its predecessor, Hubble, Webb can peer into the infrared spectrum, detecting faint signals of heat in molecular fingerprints that were previously invisible to us. Recently, this instrument set its sights on a remarkable target, an enigmatic exoplanet known as K2-12B. Initial observations of K2-12B sparked a wave of excitement within the scientific community. This celestial body was no ordinary planet. Not only did it exhibit the presence of water vapor in its atmosphere, a potential indicator of habitability, but it also revealed the possible presence of a molecule that stirred even deeper intrigue: dimethyl sulfide, or DMS. On Earth, this compound is produced almost exclusively by biological processes, particularly by microorganisms in the oceans. Could this be the momentous revelation humanity has been waiting for, the confirmation of extraterrestrial life? The discovery pushed scientists to ask bold questions. If such a molecule truly exists in the atmosphere of K2-12B, could it mean that life, even in its simplest microbial form, is not unique to Earth? Could we be staring at the first chemical whispers of alien biology from 120 light-years away? This possibility is nothing short of revolutionary, for it would fundamentally reshape our understanding of our place in the universe. K2-12B belongs to a category of planets that are still poorly understood, sub-Neptunes. Located in the constellation Leo, about 120 light-years away, K2-12B is larger than Earth but smaller than Neptune, falling into a category of worlds that defy the conventional labels we have built from our own solar system. We are used to comparing other planets with the familiar examples in our cosmic backyard: rocky Earth-like worlds, or giant gas spheres like Jupiter and Saturn. But sub-Neptunes, which are incredibly common across the galaxy, are unlike anything we have nearby. They are planets with thick atmospheres, often dominated by hydrogen, and possibly vast oceans beneath their dense skies. K2-12B orbits its host star, a red dwarf known as K2-18, in a region astronomers call the habitable zone. This is the delicate zone around a star where conditions might allow liquid water to exist on the surface of a planet, neither too hot nor too cold, but just right. However, K2-18b's orbit is much tighter than Earth's. While Earth orbits the Sun at 1 astronomical unit, K2-18b circles its star at just 0.18 astronomical units, even closer than Mercury is to our Sun. At first glance, such proximity would seem to doom it to scorching heat, but red dwarfs emit far less energy than stars like ours. This means K2-18b could maintain temperatures suitable for liquid water, provided it has a stable atmosphere. Its orbital period is just 33 days, meaning a year on K2-18b passes in little more than a month for us. This close dance between planet and star raises fascinating questions about the planet's climate and dynamics. Could such a world, locked so near its red dwarf, sustain stable oceans? Could life survive in such conditions, bathed in a different kind of starlight than we know on Earth? The James Webb Space Telescope provided clues that suggest the answer might be yes. Its infrared instruments detected not just water vapor, but methane and carbon dioxide as well, key molecules that hint at a complex atmospheric chemistry. The presence of methane is particularly compelling, since it breaks down quickly under stellar radiation and must be replenished by some ongoing process. Yet, the most extraordinary finding was the possible detection of dimethyl sulfide. On Earth, DMS has only one known source: life. Specifically, it is produced by plankton in the oceans, released into the atmosphere where it plays a role in cloud formation and climate regulation. If confirmed, this molecule would represent the first potential biomarker detected on a planet outside our solar system. Imagine that, an alien world, hidden for eons in the darkness of space, now revealing faint chemical traces of biology to a telescope orbiting far above Earth. It is both humbling and exhilarating to consider. But there is a catch. K2-12B is not Earth-like in the way many had hoped. Its thick hydrogen-rich atmosphere and immense size suggest it may be a Hycean world, a type of exoplanet proposed by scientists to describe massive water-covered planets with hydrogen atmospheres. The name, Hycean, itself comes from a combination of hydrogen and ocean. Such worlds could be vastly different from Earth, but they may still host habitable environments, perhaps deep within their global oceans or under protective layers of atmosphere. Temperatures in these environments could reach nearly 200 degrees Celsius, hot by human standards, yet still within a possible range for extremophiles, organisms on Earth that thrive in boiling springs, volcanic vents, and other extreme conditions. Astrophysicist Niku Madhusudan has been a leading voice in exploring the possibility of Hycean worlds. His research suggests that planets like K2-18b could vastly expand our definition of habitability. Instead of searching only for rocky Earth-like planets, we might consider entire classes of worlds that were once thought too exotic. If life can emerge in such places, then the number of potentially habitable planets in the galaxy could be far greater than we once believed. The task of detecting such biosignatures, however, is daunting. Even with the James Webb Space Telescope, collecting enough light to analyze the chemical fingerprints in K2-18b's atmosphere required hours of careful observation. The method used, called transmission spectroscopy, takes advantage of transits, moments when the planet passes directly in front of its star from our perspective. During a transit, starlight filters through the planet's atmosphere, where molecules absorb certain wavelengths, leaving behind a kind of chemical barcode. By splitting the light into its spectrum, scientists can decode these patterns and infer what the atmosphere is made of. It was during such observations that hints of dimethyl sulfide appeared. But Webb alone cannot yet deliver absolute certainty. Follow-up observations, perhaps with future instruments like the extremely large telescope in Chile or even next-generation space telescopes, will be needed to confirm these findings. Still, even the possibility of such a detection has electrified the scientific world. The implications are staggering. If dimethyl sulfide truly exists on K2-18b, it would suggest that life, in some form, has emerged beyond Earth. This would be a profound moment in human history. For centuries we have searched the skies, wondering if intelligence exists among the stars. The discovery of microbial life, even simple organisms, would be enough to prove that biology is not unique to Earth, that the spark of life can ignite wherever the right conditions exist. And if life can emerge on one Hycean world, it could emerge on millions more scattered throughout the galaxy. Yet, as with all great discoveries, caution is essential. Nature is complex, and sometimes molecules associated with life can also be produced by non-biological processes. Methane, for example, can arise from volcanic activity as well as biology. Even so, the simultaneous detection of methane, carbon dioxide, water vapor, and dimethyl sulfide paints an extraordinary picture. It suggests that K2-18b is more than just another distant planet. It may be a world where alien oceans cradle life beneath thick hydrogen skies. The universe suddenly feels both larger and more intimate. Somewhere, light years away, microorganisms could be releasing gases into an atmosphere, unaware that a distant species across the galaxy is watching, studying, and wondering. These discoveries force us to rethink our place in the cosmos, reminding us that Earth may not be the only cradle of life. So as humanity stands at the threshold of this possible revelation, we must ask, what comes next? Do we prepare to expand our search, to build even more powerful instruments, to listen for signals and study alien chemistry with sharper tools? Or do we pause, humbled by the knowledge that we may not be alone? The journey of discovery is far from over. K2-18B has given us a tantalizing glimpse of what may lie beyond, a spark of possibility carried across the void of space. Perhaps, one day, we will confirm that life truly exists out there, and when that day comes, it will not just be a scientific discovery. It will be a profound moment for all of humanity. Let me know what you think in the comments box. If you enjoyed this exploration of one of the most mysterious worlds ever discovered, remember to like and subscribe. Share this story so more people can join in asking the great question, are we truly alone? Because the answer may be closer than we ever dared to imagine.